We are continuing our discussion on collisions, and we are taking the situation from where we left it last time. We had done the law of conservation of momentum and seen what it means. That is, unless an external force acts on a system, internal forces cannot change the momentum of the system. But of course, velocities can be gained or lost and so on, but the total momentum does not change. So let us now see if we are in a situation to apply that knowledge to figuring this situation out. So in the given situation, we have a billiard ball which is stationary V2, which is equal to 0, and another billiard ball which is heading towards it with a certain velocity V1. Because they are both made with identical materials and have identical dimensions, we say that the mass of one is equal to the mass of two, m1 equals m2. So then an event take place, the two balls collide with one another, and then we figured out that there are four possible scenarios for a one-dimensional collision to take place, unidimensional collision. So it's not a two-dimensional collision, they just collide head on. So the first situation we realize is that the two billiard balls will gain a velocity and they can go in opposite directions. Okay, the prime over here of course means that this is the velocity of the billiard balls after the collision. Then situation B, where one billiard ball sticks with the other billiard ball and they go off together with a certain new velocity simply called V prime, because it's not the velocity of one ball or the other, it is the velocity of both the balls together. In fact, we could also call this V prime 1 2 or 1 comma 2 for both objects if you like. Then situation C will be when both of them collide and then they gain different velocities and they move off towards the right. And then last situation, the situation D, in which the the ball that collides into the stationary ball, that completely stops, and then the other ball moves away, and the condition that was stated in this was that therefore V2 prime should be equal to V1, which is the velocity before the collision took place. So I'm saying, is there any other statement that you would like to make about A, B, C and D, or any other condition that you would like to put to this situation? Right. Anything anybody is able to see or figure out? Yeah, Prakriti, go ahead.
So for the fourth one, I mean D, I think it's possible because the momentum of the billiard ball before it crashes is m1 v1, right?
Yeah,
So
yeah,
when it crashes, if it transfers all of its momentum to the second ball,
yeah,
then it has to stop, because then if it's still moving, then the momentum won't be equal, right? If it's zero, then it will be equal. So
yeah.
then you can say that this works.
Great. So yeah, so the thing is that to say what is possible and what is not possible, or how it will be possible, or whether whether it is impossible, the only thing that we have is the law of conservation of momentum. So you have to see whether the conservation of momentum is being maintained over here or not. So if you see before the collision, okay, what is the momentum of the object? It will be m1, momentum of the system rather, m1 v1 plus m2 v2, right? And we
Yeah.
know that v2 is equal to 0. So basically it is m1 v1 plus 0, which is equal to the same m1 v1. Okay, so this is the total momentum that is possessed by this system, and assuming that none of these collisions involve any external forces, it does. Obviously, there is some friction on the table along with the billiard ball because the base has some friction on it. But for the tiny instant of time during which the collision takes place, right? For the tiny instance of time when the collision takes place, we can ignore the effects of friction and say that at that point of time, there are no external forces involved. The forces involved in the collision are completely internal. For we can assume things like that, okay? If you have any problem with that, let me know. So during that period of time, we can say that since no external forces are involved, the total amount of momentum in the system must always remain m1 v1. If there is any violation of, if there is any increase or decrease of momentum in any of these situations A, B, C or D, then that situation will naturally be invalid. Okay, and one another condition exists that I would like to remind you, we might forget that, is that the masses of the two objects are exactly the same. Okay,
Yeah.
so we are concluding that situation D is perfectly possible, because we are saying that in this case what happens is that since sorry, bad color choice, since v1 prime is equal to 0 and v2 prime has become equal to v1, right, we can then say that since the masses both remain the same m1 m2. Okay, so look at the momentum that is there in the system over here, forget about this, just look at the momentum in the system. The momentum will be क्या हो गया, m1 v1 prime plus m2 v2 prime, correct? v1 has become equal to 0, so basically this whole thing becomes 0. So what do you have over here, m2 v2 prime. If the condition is v2 prime is equal to v1, right, then we can rewrite this as m2 v1 prime, m2 v1, and
Yeah.
since m2 is equal to m1, I can write this as m1 v1. Are you able to
V1.
see that bit, m1
Yeah,
v1?
yeah.
Yeah,
Yeah,
so
sir.
Yeah.
since the momentum is m1 v1 and that is the original momentum in the system, situation D is a valid situation, correct?
Yeah.
Yeah, sir.
Yeah.
So this is doable. So similarly, now try to see if you are able to prove the other situations, whether they are plausible or they are not plausible. Go. Yes, Prakriti, you were saying something.
Yeah, so when the billiard balls move together, the mass doubles
Situation.
and the, yeah, in situation B,
Yeah.
and the velocity decreases by half.
Yeah. So
Momentum should stay the same.
yeah, yeah. So in this case, and this is the only case in which we can talk of m prime. Okay, the m prime is equal to m1 plus m2. There is a new mass, isn't it? Because they both have somehow stuck together. Maybe somebody put a little bit of a glue there or some hot wax that it got stuck to one another, and then they are moving in the same direction. Velcro is a good example. Okay, so then since m1 is equal to m2, the mass has doubled. So therefore, if this situation has to happen, it can only happen by v prime being equal to half of v1. Okay, and you can work it out now. You can apply the same equation that I gave over here, m1 v1 prime plus m2 v2 prime. Except in this case, you will have m1 plus m2 multiplied by v prime, and you will see that this can be true only if and only if v prime is half of v1. Only then momentum is conserved. No other way momentum is conserved. So we have given the condition by which this can be true, and it is also practical because you can stick something like velcro or something like that. Like say for example, these billiard balls can be made of these balls can be made of wet clay. Then when
That
you
can happen with magnets also.
with magnets also. So if they are wet clay or
Magnets is the best.
can stick together, and this situation is possible. So we have proved that B and D are physically and practically possible. How about the other situations? I'm waiting for others to come up with
Can
proof.
you pause the recording once?